Discussed about reverse breakdown voltage and reverse characteristics or reverse bias characteristics of PN junction diode. So this point is very important. This point is known as need point. So now look at the range of ammeter. So here I am using only microampere ammeter because the reverse current or the current flowing through the reverse bias is very minimum when compared to forward bias. So during forward bias we used milliammeter, but here it is microammeter. It means the amount of electron crossing from cathode to anode is very less when compared to forward bias. That's why I am using microammeter. And this point is need point. If the voltage, if the applied voltage or voltage across the diode exceed the breakdown voltage, the current starts increasing rapidly. It may damage your device. When the current increases, the heat produced at the junction also increases. It may damage your diode. So you should not operate your PN junction diode above reverse breakdown voltage. And this is the definition of reverse breakdown voltage. If the diode is in reverse bias condition, up to the breakdown voltage, the depletion layer would be wider and corresponding current would be almost zero. Almost zero means it is in the order of microampere. Microampere means it is close to zero. But when the voltage increases above breakdown voltage, if they increase the voltage further to this breakdown voltage, the diode gets overheated. Why it is overheated? Because there is a short circuit. So there is an excess amount of current flow through the diode. That breakdown is known as avalanche breakdown. Even though the voltage remains the same almost. So it means the 50 voltage is constant. Even though the voltage is constant, the current is still increasing. So the current increases tremendously, which may result in the failure of the diode. Reverse current is mainly due to the minority charge carriers in the devices. Minority charge carrier means if it is a p-type material, the majority carriers are holes, the minority carriers are electrons. If it is an n-type material, the majority carrier is electron, the minority carriers are holes. So this is reverse breakdown voltage. If the voltage is 0, the current is 0, but when we increase the voltage up to 20, the current is in the order of nanoampere. If we further increase the voltage, the current, there is no change in the current, but at certain voltage, your diode will become a short circuit. So there is a tremendous increase in current. So this voltage, this potential is known as breakdown voltage or reverse breakdown voltage. So this excessive amount of current, it may damage your diode. So this is the VI characteristics, complete view of your PN junction diode. So this is forward bias, we are using milliammeter, and during reverse bias we are using microammeter, because during reverse bias the current is zero, almost it is close to zero. This region is a knee point. This voltage is reverse breakdown voltage. This voltage we call it as forward breakdown voltage. If you see the diode data sheet, they have mentioned the operating voltage. If it is 1N4001, the operating voltage is 50, or the maximum recurrent peak reverse voltage, RMS voltage is 35, 70, 140. In our laboratory we are using 1N4007, the operating voltage is 700. The DC blocking voltage, so this is a maximum reverse voltage diode can withstand is, if it is 1N4001, it is 50 volt, for 1N4007, 1000 volt. Similarly, you can see the average forward current, it is 1 ampere. The reverse current is approximately 30 microampere. So this is a reverse current. So these are the ideal characteristics of a diode. During forward bias, your diode acts as an on switch. So turn on time equal to 0, your on state resistance 0. So if there is no resistance, there is no power loss, so no voltage drop. It should allow infinite current. Width of the depletion layer is 0, because there is no depletion layer during conduction. So it should withstand infinite temperature. So this is the characteristics of diode during reverse bias. Turn off time equal to 0, infinite resistance during off state, and it should not allow current because it acts as an open circuit. And the reverse blocking voltage or reverse breakdown voltage should be infinity. It should withstand infinite amount of voltage during reverse bias. Width of the depletion layer should be maximum. Off state power loss equal to 0. And it should withstand infinite temperature. So this is an ideal characteristics of a diode. ideal VI characteristic, ideal diode VI characteristics. This is voltage and current.